All right, so my name's Jeff Kolesnikowicz, and I hate public speaking, although I'm here. I'm brand new to public speaking. I've been doing it less than a year. I do want to encourage all of you to get out. You all have a story to tell. You've all done something interesting, I hope. Get out there, talk. This is, a year ago I had never given a talk. Now I've given a talk in 3 different countries. And I'm still nervous. You should see my back. It's covered in sweat. So I work at Allied Health Media, and I do want to say thank you to them. They are paying for me to come to these conferences, and I did want to mention that they're hiring. They're hiring a senior dev right now and a QA analyst. So if you know anybody, please let me know, or send them to alliedhealthmedia.com. So, and yeah, you don't have to spend the full amount to come to these conferences. You can not pay attention to these conferences. If you're a speaker, you get your ticket comped. I'm sure Larry over there is thrilled that I'm saying this. So what am I going to be talking about today? I'm talking about WebSockets and real-time communication between the browser and the server. We're going to talk about where WebSockets are used, how I used WebSockets, and some of the pitfalls I encountered while using WebSockets. And also, hopefully, you'll learn why you should use WebSockets. I do want to mention that WebSockets are hard. This is not the easiest thing in the world. It's a little niche in the web development world. I'm not trying to throw cold water on your enthusiasm. I'm not trying to dampen it at all. But I do want you to know that it's a difficult and sometimes fussy thing. This talk is really for those people, you know, back in college or university when you first discovered network programming and you would build a little network server and you would telnet into it and type something, and then it was the greatest thing ever when the server would echo what you typed on the screen because you were communicating over that. This is a talk for those people. So I want to get a few definitions out of the way. We're talking real time here, and the purpose of real time is to update our web pages in real time from the server, push data out to your browser. As web pages have increased in complexity, we've changed our approach to getting new data to the browser. Real time is the goal. We want to update the web page with new information as soon as it's available. And the question becomes, how do we get new information from the server to the browser? So we have half versus full duplex. Half duplex means the communication is one way. So the browser can talk to the server and the server can talk to the browser. That's not real time. What we want is full duplex, where the browser and the server can talk to each other at the same time. So this is the old way of getting information from the server to the browser. We would refresh the browser. And there's still a few websites out there that do that. And if you think about it, most applications are built this way. You get new users, your user page, your listing of users doesn't change until you refresh the browser. And then Ajax came along. And what Ajax would do is poll the server. Every few seconds or minutes, it would send a Ajax request out to the server and say, is there anything new? And the browser would update if there was. So this is half duplex. The browser can ask something of the server, but the server can't ask anything of the browser. We also don't know who's connected to the application between polls. All we can do is test the polls, or test to see who's updated their data most recently. And this certainly isn't real time. Devs have tried to make it seem real time by shrinking time between the polls, but it's not real time. It's also server intensive, and it can be really slow. Every time when your browser makes a request, you're firing up an HTTP request, and that can take some time. And if you have, say, 1,000 browsers looking for new information, that can really tax your server. So along came long polling, and this is what Facebook uses in their chats. They implemented this because WebSockets weren't widely adopted when they built the news feed or their chat. And what this is the browser sends a request and says, tell me when something new is coming out. And then that request might sit there for 10 seconds, 30 seconds, a minute. And then when something new comes out, it sends the updated information out to the browser. At least we know, this still isn't real time, but we know who's connected to the server. All the waiting is done in your PHP application. You wait until something new happens, then you finish loading the page. And there's a downside to this. You need a specialized web server. Otherwise, all this polling is going to eat up your web server's worker threads. And again, it's closer to real time, but this isn't asynchronous. Your server can't ask anything, your web server can't ask anything of the browser, and you don't necessarily know who's connected. And here's an example. This is blatantly stolen from Stack Overflow, by the way, but this is an example of long polling. So the top part is a request. Randomly, it'll fake an error. Otherwise, it's going to sleep for somewhere between 2 and 10 seconds and then spit out a random number. So this is the new hotness, full duplex WebSockets. And this is real time. So your browser can talk to the web server can talk to the browser. You can request things from either way. Your WebSocket server can say, can disconnect your browser. Your WebSocket server knows who's connected once you've authenticated. And either side can terminate the connection and the session is over. The downside to this is there's no sessions built in. You'll have to authenticate your user somehow. The way we worked around it was to send a hash that only we knew the secret to, how that hash was built. If the hash authenticates against the server, then we consider that server or that client authenticated. So WebSockets are part of HTML5, and they're an attempt at real-time communication for browsers. They are full duplex, and what's also interesting is they're accessible from non-browser applications. And like I said in the last slide, they're built into most browsers. You'll see that this chart starts at IE11. However, you're going to see a red sliver there over the IE side, and that's IE 9, 8, 7, etc. So in the real world, we use WebSockets on social feeds. We're going to update your feed in real time. So as somebody types something, you're receiving the information, you're sending all that information out to everybody else. It's great for chat applications. And implementing a WebSocket chat is really quite simple. I have some code samples free for everybody today. You can take it home and use it how you want. It's also good for online games. And this is where we used it. We have an online training tool for speech pathologists, and I'll talk about it in a few minutes. But what we do is we score, our scoring logic happens on the server, and then it sends the results back to the browser. A lot of games build their scoring into the browser, which is easily hackable. And I'll talk about that in a couple minutes. Following this technique keeps your scoring separate from the user and possible tampering. WebSockets are also used in collaborating on documents. Trello actually uses WebSockets to push data to collaborators. So as you're clicking and dragging things on Trello, and they do fall back to Ajax. So if you can't form a WebSocket connection, it will fall back to Ajax. And WebSockets are used tracking live data. So sports scores, financial tickers, push that data out, updates the user's browser. So the trick to PHP is, WebSockets in PHP, is you have to run a WebSocket server separate from your web application. And that's where we get into some trouble sometimes. You need to build both sides. You need to build a WebSocket server application, and you need to build the browser side, the way to talk to the WebSocket application. You don't get anything for free built into PHP. You have to use well, you don't have to, but I highly recommend using a library. I'll talk about that in a sec. And this is an example of traditional sockets. So this is for those nerds that built, like me, who built that little socket application. You tell that to port 8000, and it'll spit back out what you've typed. So the difference, so this is a WebSocket handshake. So you'll notice the browser will make a request to /chat, and then the web server, your web server is going to respond with an upgrade 426 request. If your browser says, I don't know what to do with this, the web server knows that your browser isn't compatible with WebSockets and will terminate the connection there. Otherwise, it sends another switching protocols request, and it switches to a stream, which is a a telnet session similar to that, something similar to the telnet session. Now, this is a PHP conference, and I don't want to talk about JavaScript too much. But if you're starting a WebSocket application from the ground up, you might want to look at Node. And one of the pros is you don't have to run a separate WebSocket server if you're using Node. There are libraries that are built that come with Node that you install in your Node application. You're done. But then you're working with JavaScript. I'm kidding. And it's difficult if you're extending an existing application built in another language. So if you're building on top of a WebSocket application, or sorry, a PHP application, and you want WebSockets built in, it's pretty difficult to do that with Node. You would have to, it would look something like this. You would have to, you would have that extra hop. You would go from the game front end or your WebSocket application to the Node.js back end, and then you would do API calls to your PHP application. And that's not really real time. You can't really push, you could push data from your PHP application to the Node.js backend, but that would take some fancy footwork. So with PHP, we have a library called Ratchet. And it was written by a guy named Chris Bowden, and he's a Canadian, which makes him awesome. I'm Canadian, by the way. And it'll really help your application to build it with Ratchet. It comes with a WebSocket server. The point is to use a WebSocket server. So this is what a basic WebSocket server looks like built in Ratchet. So like I said before, you're still using a HTTP request. So you'll see that it comes with an HTTP server and then a WS server, that's the WebSocket server. And then on the inside, on the inside of the WS server, you have a chat object. And that chat object is your business logic for your application. That's what you're going to implement. So don't worry if you can't see this. I'm going to go into more detail, but this is implementing a really basic chat application. As you connect to it, you can chat and send chats or messages to other people who are connected to the server. That's all this does. This isn't anything groundbreaking. It's really pretty basic. But let's look at it a little more. So message component interface, that comes with Ratchet. So you have to implement that in order for this to work. And what it does is it gives you a whole bunch of hooks. We have a list of clients, and we're calling that an SPL object storage. And as users connect to our WebSocket application, we connect them to the SPL storage. So we know who's connected to the application. So this is one of the first methods you need to implement on open. And then what we're doing here is, like I said, we're connecting it to the SPL storage, and then we're printing out that somebody's connected. Similarly, on close. So what do we do when somebody disconnects? We're going to disconnect them, spit out a message to the screen. And we're just cleaning up our storage so we know who's connected, who's not. So this is a little trickier, not really, but on message, when somebody sends a message, we receive that request, and then we're looping through our list of clients. And if the person who sent the message isn't the person, if the person who sent the message is in the list of, well, they're going to be in the list of clients, it's not going to send it to that client, but it's going to send it to everybody else. On the client side, we have very similar hooks. We have the on-open, on-close, and on-message. So on-open, on the client side, this is just setting up what our browser is going to look like. That's all that set online method does. On-close, we're just disconnecting, and we're setting our browser to look like it's offline. And on-message, we are printing off what message we received in the browser. And here's to send a message. We're just using con.send. The con is our connection we established here at the top. So they say not to do a demo when you're giving a talk. So let's do a demo. Okay, so can everybody see that, or is that too small? Okay. So we have our WebSocket server running here. Yeah. So let's connect one host, and we type something, hello, CakeFest. And you're going to see it's going to print it here. This is our WebSocket server, but it's not going to print it here because we're disconnected. Once we connect, we're not going to receive that message yet because we weren't connected when the initial message was sent out. But here, we're going to see both browsers get it. One of the downsides to WebSockets is if your browser or if your server goes offline, if it crashes or somebody cancels it, which I'm going to do right now, you're going to see you get disconnected. So the way to deal with this is to build logic into your front end that handles your WebSocket server going down. Either attempt to reconnect, let the user know that you've crashed, or whatever your business logic is. There we go. And that's available here. I have a GitHub repo for you to get started. It's a really basic WebSocket application. This will be up again later, so you can copy it then. So somebody decided WebSockets weren't good enough, so they came up with the WAMP protocol. Not good enough, I don't mean that. They wanted to extend how WebSockets were used. So they came up with the WAMP protocol. And what we get with WAMP is two different paradigms. We get remote procedure calls, and what that means is your browser can make certain they can make custom calls to functions on the server, and they can call it when they want, how they want. And this is intended for one-to-one communication with the server. So something like a game. You need to update the score, so you call scoring on the server. And this can be used to request data, direct communication between browsers, and, like I said, games. And the server can make a request to the browser. The other paradigm is pub/sub, and that stands for publish and subscribe. So this is something like a chat. So you connect to a WebSocket server and you connect to the chat and a channel, maybe a channel like IRC. And as the server receives requests or chat messages, it sends it out to all the connected clients. And this is a lot more scalable. However, your client cannot request information outside of what is published. And yeah, so it can be used as a chat or updating information between networked connections. So now we're on to how we use WebSockets. So I'm sure everybody's been in this situation, but the company I am at, sorry. They don't know I'm quitting? No, I'm kidding, AHM, I'm not quitting. We used WebSockets, or they wanted a game built, and all the devs were busy, so they outsourced it. And they got a bunch of RFPs, and unfortunately they went with the cheapest one. And so they built this application using Ajax, and the Ajax requests would come and go, and every Ajax request, there was a delay of 5 minutes between each Ajax request. So a user would be in the game doing something, and after the web browser would update after 5 minutes, but sometimes the browser would crash, and the user would lose up to 5 minutes of gameplay, and that, obviously upset a lot of people. So scoring was done in the application, and that was another problem. 5 minutes after we accepted the application, one of the devs gave himself a score of 100% simply by breaking open the JavaScript console. So we rebuilt it using WebSockets, and this is the architecture we used. So as the web browser connects to our server, it goes through nginx, and nginx does the load balancing, and load balances between 3 WebSocket servers. And this all happens over HTTPS, and nginx forwards the request to the WebSocket servers, which are living on port 8000. You can't connect directly to the WebSocket server. That you have to go through nginx, it's firewalled. And then the WebSocket server is actually using the code from the legacy application. And the result of that was an Ajax request would take anywhere from 500 milliseconds to 1500 milliseconds, which is ridiculously slow. It's not real time. You need to score your application. You can't wait a second and a half. You're going to upset your user. Obviously, the security was poor. You can change your score in the console, and we would have a lot of support. You would have a lot of support calls, and you don't know who's connected. So with WebSockets, the latency went down to less than 100 milliseconds. I might have made up that percentage for security. It's not actually 648% more secure. And the stability, we did have a 50% drop in support calls, and we do know who's connected. And this is a screen we have in our application. I've hidden the member names and everything, but we know who's connected. On this screen, the WebSocket server has been up since Friday morning at 6 a.m., and it's been up for 6 hours and 49 minutes. and we have 35 connections on this server. So we actually have one of these screens for every single server. So really, we've switched our application from Ajax to WebSockets, and we've solved all the world's problems, right? Not necessarily. So this is where I want to impart some of my knowledge onto you, and hopefully you can if you're looking at implementing WebSockets, you can take some of these little bit of hard-earned bits of knowledge I've gathered, but do beware. Once we got to production, we had a whole lot of crashes. And this is a PHP core dump. And does anybody see the problem? No? Sorry? Indeed. The problem here was caching. So we used our Redis server to authenticate users. And the issue here was that when you load a web page, when you connect to Redis, Redis assumes you're only making a short connection. So we had to turn off persistent connections because Redis would cut off the connection halfway through. So that would our WebSocket server would die because Redis wasn't there. Does anybody know what a ulimit is? Because I sure didn't before this. Everything in Unix is considered a file. A socket connection's a file is a file. I think even a folder's a file, but you can correct me on that. The issue here is that PHP is expecting there's limits on how many files you can have open. PHP has a limit of 1,024 files by default. You can have 1,024 files open at a time. So if you're opening socket connections, closing socket connections, PHP requests from the server it's on, I need a socket connection. And the server hands back a file descriptor, and part of that is a number. And a ulimit tells your server how many open files you can have at a time. Again, PHP 1024. By default, Unix 65,535. So PHP will say, give me a new socket connection, and the server will hand back a socket connection above 1024. PHP goes, and crashes. So what we did, our solution for that was to create a new user for our WebSocket connection to run on, and set that to only have 1,024 connections per server. So that also creates a bit of a problem in that we can only have 1,024 open socket connections at a time. So that creates a limit on each server. However, it doesn't crash anymore. We also had our web application was built for universities and colleges, and as I'm sure you know, they tend to lock down their network as much as possible. So they're going to look at this WebSocket connection and say, I don't know, I don't recognize this. This isn't a standard request, and discard it. The way around that is to use secure WebSockets, WSS, and that tends to get through proxy servers. If you have a good relationship with your client and they're having connection problems, you can get them to use websocket.org and figure out if that is the problem, and then you can switch to, that'll help you diagnose it, and you can switch to secure WebSockets if that's the issues. And PHP isn't really intended to run 24/7. And obviously we need to run it 24/7 in a WebSocket connection. So we still had random connection problems. We still had, I'm not sure if it was memory issues, but restarting our server once a day at 6 a.m. took care of our problems. We've been running our WebSocket connections for 2 years now, and we haven't had a problem with that. So nginx looks like, our configuration of nginx looks like this. You connect to port 443, and that forwards you on to the WebSocket servers. We are going to switch to HA Proxy probably at some point. And nginx works, but it might not be the best. But here's our nginx configuration. So if you look at this, the top part defines our WebSocket connection, and then we're defining which WebSocket servers are available. So they're all living on port 8000, and they live at those IP addresses. The URI here, web/WebSocket, any request to that gets forwarded on to the WebSocket. And we have, where did it go? In that second bracket, we have the least con, and that is the load balancing strategy. And there's 5 different strategies nginx has for load balancing. We have least con, so the least number of connections. It's going to, any new request is going to go to the server with the least number of connections. We have round robin, so it just default cycles through the servers you have. And then I'm not a server admin, so I'm not sure what an IP hash is. And then we have least time. So the WebSocket server with the least latency for that user. I'll bet you didn't know that there's no WebSocket server monitoring service out there. Pingdom doesn't monitor WebSockets. All it does is, well, ping your servers. So that's a business opportunity for somebody here. Load balancing, it helps. It helps with connectivity, but it still requires a number of failures before it's down. And I'm not sure what that limit is, but it's something like 5. So you might still have 5 connections to your WebSocket server before nginx realizes that it's down. And we really have to monitor our infrastructure. So, and you're adding a new server to your application, so you need to monitor that. We wrote a custom script that pings every 5 minutes, and it just cycles through our servers and pings the server. If the server's up, no problem. Otherwise, we send a message to Loggly, and Loggly will notify us if there's a certain number of down connections. We also use Newrelic to monitor processes. So this is actually our application running, and you can see it uses about 35 megs of RAM and uses very little CPU, but this does help monitor what we're doing. All right, so I do find WebSockets, they're more robust. It's than just using Ajax. It's an interesting little corner of web development, and if you have a specific use for them, go for it. I mean, it's really, it's a nerdy, sort of interesting corner of web development. If you're starting from scratch, and depending on your use case, you might want to look at Node. If you have a legacy application and you need to communicate from your WebSocket server to your browsers, you want to look at Ratchet. And make sure you support your WebSockets server properly, monitor them, and try to avoid the pitfalls that I came across. So here's some extra links. The GitHub link is there. That'll get you started with WebSockets. Ratchet's there. The more reading on the WAMP protocol, and of course Node.js. Any questions?
Would you ever consider building a socket server in something that wasn't Node, like with Go or with Rust or something that isn't more JavaScript?
Yeah, absolutely. You're still going to write JavaScript on the front end. So you're not getting away from JavaScript.
That's true.
Now you can build WebSocket servers that connect, or WebSocket servers in PHP and talk to it in Rust, or talk to a Rust client. I mean, if you really want to. Okay, no other questions? Thank you. Oh, there was?
No, I just wanted to ask about, let's say, like, managing the messages that are coming from the WebSockets and all that. Do you think that's outside of the scope of what you talked about here? Is that more of like a message queue kind of functionality?
Yeah,
and the
that's more of a
WebSockets is
message.
just like the communication?
Yeah.
Okay, thanks.
I'm happy to talk to you after if you want.
Yeah, no, I was just wondering like where you think it fits in. If it's in this or
It fits outside of this, I would say. That's what we use Redis for.
okay.
Yeah.
So is it possible to do like RPC and pub sub?
It is.
You just have to open 2 socket connections?
You
per
don't.
client?
You're kind of blending the paradigms, though.
Well, like if you had one user that was connecting, say playing a game, and they wanted to interact, have a battle, do maybe pub sub for that, but then, no RPC for that, but then pub sub for like a chat window on the side.
You could do that.
Okay. And you wouldn't need to do 2 socket connections per client, or you would?
No, you wouldn't. You could do that, yeah.
Okay. Cool.
Cool? All right, thanks.